So where do fatty acids come from? When we look into milk fat, we're all pretty used to looking at that data. But when we look a little more detail into milk fat composition, we see that 92 to 95% is represented by fatty acid. The other 5% comes from glycerol and other molecules. Looking at a fat molecule, it's composed from a glycerol, which is the top section here, the vertical section here, and to this glycerol are attached fatty acid. In this example here, the first one is a saturated fatty acid, meaning that there are no double bonds. The second one here in the middle only has one double bond, so it's a mono unsaturated fatty acid. And the bottom here, we have two double bonds, so it's a poly unsaturated fatty acid, meaning that there's more than one double bond. So when we analyze fatty acid in milk, we realize that there are more than 400 different fatty acids. In our lab, we do not analyze the 400, but we do group them into three categories. So we have the short chain fatty acid that will range from 4 to 14 carbons. So a C4, meaning that there are 4 carbons in this molecule. So the length is a little shorter than, for example, a C10 when there are more carbons attached to it. So those are considered short chain, and they are in the category of the de novo fats. Looking at mixed fatty acid, they can be coming from C16. So C16 might not be telling you a whole lot, but if you do feed palm fat to your cows, palm fat contains a lot of C16. So we might be able to see that in the milk fatty acid profile. And then we have the preformed fatty acid that are composed from long chain fatty acid. This one here is a C18-2. So 2 for the 2 double bonds that are here. And we find a lot of C18-2 in grains, such as corn and cereals. So we group fatty acid into three categories: the de novo, that are synthesized in the mammary gland coming from the rumen fermentation, so they do reflect rumen health. Then we have the preformed fatty acid that come from feed and fat mobilization in the mix that are a combination of the other two categories. Looking into de novo fatty acid, it starts from feeding the cow. So when we feed the cow starch and fiber, it goes into the rumen, where the rumen bugs then work at it, and they produce fatty acid. So the three main fatty acids that are produced are acetate, butyrate, and propionate. These fatty acids will then exit the rumen and go into the mammary gland, where de novo synthesis will occur. So for example, if we look at a 16-carbon de novo fatty acid synthesis occurring in the mammary gland, it starts with a butyrate, and then acetate molecules are attached to it until the de novo fat is completely synthesized. And then this de novo will be found into milk fat, and that's how we're going to analyze it. Now looking into preformed fatty acid. The preformed fatty acid come from fat mobilization. So when cows are losing weight, for example, fresh cows in early lactation, they will use their fat reserves, and these long chain fatty acid will go in blood, and then they will be found into milk fat. The other source of preformed fatty acid comes from feed. So if you're feeding protected fat, oil seed or oils to your cows, and haylage and corn silage also contain fat percentage. So some of these fat coming from feed will also be found in the long chain fatty acid that are called the preformed fatty acid. So as a short summary, de novo are synthesized in the mammary gland, and they do come from rumen fermentation. So they do reflect rumen health. Preformed come from feeds or body reserves, and then the mixed fatty acid can be impacted either from feed or from de novo. So if you're feeding palm fat, this is the category that might be affected here with preformed that will show in your milk profile. So milk fat and its fatty acid profile. So if we look at this example here, we represented two farm profiles. They both average 4% butter fat, but when we look a little more detail in the fatty acid profile, we see that that 4% is represented by different amounts of de novo, mixed, and preformed. So farm 2 has higher levels of de novo fat than farm 1, but they can both achieve similar with different fatty acid profile. So this is a document here that you can find on our website, and you can go on and download it. These are the 3 categories of fatty acids that we work with, and these are a little few elements to look for depending where your profile, what your profile looks like. So looking into de novo fats, they are synthesized in the mammary gland and they do reflect rumen health. So if they are above average, it means that the rumen is healthy and that there's a good microbial function going on. However, if the de novos are below average, and there's a few things that we can be looking for. So degradable starch or degradable protein. So remember that the rumen buds, they use starch and protein as feed in order to produce fatty acid that can be then moved to the mammary gland to produce de novo fats. So if we are not feeding the rumen bugs accordingly, we will not optimize the output of de novo. So that's why we link it to the amount of starch and protein. We also want to look at effective fiber, making sure that the cow is always filled and that she has something to ruminate. If there's too much fat in the ration, it can reduce de novo production. It can also be linked to a poor rumen function, ruminal acidosis, and poor management. So if there's competition, feed sorting going on at the bunk, empty feed bunk, those will all contribute to lower de novo production. Looking into the mix category, as mentioned before, mix are affected by de novo and by preformed. So if you supplement palm fat, so if the mix might be above average or they might go up, right? So we can see the addition of palm fat into the diet. If the de novo synthesis increase, you made a change and something is going better in terms of de novo, sometimes the mix will also follow that trend and they might go up or they might be above average. If mixed are below average or trending down, you can look at did you remove palm fat from your ration and anything that affected de novo. So if the de novo production goes down, mix might go down as well. The third category is the preformed fatty acid. So preformed comes from feed and body reserves, and they reflect dry matter intake and mobilization. So if preformed are above average or trending up, maybe you change forage and that forage contains more fat. Maybe the cows are eating more, the intake is going up, maybe they're losing weight and mobilizing reserve, and that's why the preforms are trending up. And if you added any type of protected fat or rich ingredients that contains a lot of fat, you might see the preform go up as well. If the preformed fatty acid are below average or if they are trending down, maybe the dry matter intake is going down, cows are eating less, maybe there's lack of energy, or maybe you change forage and the cows are the fat proportion in that forage go down, so the preform will be trending down. So those are all solutions that you can be looking into. And again, this document is available on our website, so if you want to go on and download it, maybe you can find a few things that you can be looking into depending on your milk fatty acid profile. Thank you.